Ladies and gentlemen, stargazers, dreamers, and curious minds alike, welcome to this extraordinary journey through the cosmos, right from the comfort of our own backyard. Tonight, we're embarking on an adventure that bridges the vast expanse of space with the simple wonder of looking up at the night sky. Imagine, if you will, a celestial visitor hurtling through the darkness, a frozen wanderer from the outer reaches of our solar system, carrying secrets from billions of years ago. That's the magic of comets, those icy nomads that light up our skies and remind us of just how small yet connected we are to the universe. And today, we're not just talking about any comet, we're diving deep into the captivating story of Comet C 2023 A3, better known as 3IATLAS. This isn't your average stargazing session. This is a live, unfiltered quest to capture its elusive glow with a powerful telescope. Stick with me through every twist and turn, because by the end, you'll not only witness the raw beauty of this cosmic phenomenon, but also gain a profound appreciation for the science that makes it all possible. Trust me, the revelations waiting at the finish line will leave you awestruck and eager to explore the stars yourself. First, let's set the stage with a bit of cosmic context to truly appreciate what we're about to attempt. Comets have fascinated humanity for millennia. Ancient civilizations saw them as omens, harbingers of change, doom, or divine messages. The Chinese recorded them as broom stars sweeping the heavens, while the Greeks named them kometes, meaning long-haired for their glowing tails. Fast forward to modern times, and we understand comets as primordial leftovers from the solar system's formation about 4.6 billion years ago. They're mostly ice, dust, and rocky material, orbiting the sun in elongated paths that can take them from the frigid Oort cloud, a distant shell surrounding our solar system, to perilously close to our star. When they approach the sun, the heat causes the ice to sublimate, releasing gas and dust that form those iconic tails, sometimes stretching millions of miles long. These tails aren't just pretty, they're windows into the early solar system, preserving volatile compounds like water, ammonia, and methane that could even hint at how life-seeding materials arrived on Earth. Now, zooming in on our star of the show, Comet C 2023 A3, 3IATLAS. Discovered in January 2023 by astronomers at the Purple Mountain Observatory in China, Tsuchinshan, and independently by the Atlas Survey in Hawaii, this comet quickly captured the attention of the global astronomy community. It originates from the Oort cloud, that vast reservoir of icy bodies at the edge of our solar influence, and its orbit brings it on a rare visit to the inner solar system. In 2024, it put on a spectacular show, reaching perihelion, its closest point to the Sun, on September 27, 2024, and becoming visible to the naked eye in October of that year. At its peak, it shone as bright as magnitude 0, rivaling some of the brightest stars, with a stunning tail visible from dark skies. Observers around the world reported it as a great comet, one of those rare events that happen maybe once a decade. But time marches on, and as of August 24, 2025, the comet is outbound, fading as it retreats back to the depths of space. Current observations from reliable sources like the Comet Observation Database and astronomical updates peg its magnitude at around 16.8, much fainter than its glory days, requiring a good telescope to spot. This dimness makes our hunt today all the more thrilling. It's like chasing a whisper in the wind, a test of patience, technology, and the sheer joy of discovery. For those new to the lingo, let's break down what magnitude really means. It's crucial to understanding why this observation is such a challenge and why succeeding feels like a triumph. The magnitude scale is how astronomers measure an object's brightness in the sky. It's a logarithmic system, meaning each step of one magnitude represents a brightness difference of about 2.5 times. Lower numbers, even negative ones, indicate brighter objects. Think Venus at -4 or the full moon at -12. Higher magnitudes mean fainter sights. The naked eye can typically see down to about magnitude 6 in dark skies. At 16.8, Comet C 2023 A3 is well beyond that, invisible without aid. This scale dates back to the ancient astronomer Hipparchus, who ranked stars from 1, brightest, to 6, faintest. Today, we've extended it with telescopes and instruments that peer into the dimmest realms. Spotting something at magnitude 16 requires not just any scope, but one with significant light-gathering power, clear skies, and precise tracking. That's why our setup today is no joke. We're using a high-powered telescope equipped with advanced optics, capable of resolving faint details that would otherwise be lost in the cosmic noise. Before we dive into the live capture, let's build some excitement by revisiting past comet triumphs. These aren't just old stories. They're proof that with the right tools and persistence, anyone can unlock the universe's wonders. Take Comet Churyumov-Gerasimenko, famously visited by the European Space Agency's Rosetta mission in 2014 to 2016. That comet, often called 67P, revealed a duck-shaped nucleus spewing jets of gas, teaching us about comet composition and even detecting amino acids, building blocks of life. I've captured similar views live, watching its faint glow dance across the frame. Then there's Comet Borrelli, imaged by NASA's Deep Space One in 2001, showing a potato-like body with active regions. Observations like these highlight comets' diversity, some fluffy and bright, others dark and stealthy. Remember C 2022 E3ZTF. In early 2023, it graced our skies with a greenish coma, visible to binoculars, and I tracked it as it looped around the sun, its tail fanning out like a cosmic peacock. The brightness surges were mesmerizing, peaking at magnitude 5. And who could forget Comet Leonard C 2021 A1 in late 2021? It swung close to Venus, developing a stunning ion tail disrupted by solar winds, and I caught it nestled near a star cluster, the stars twinkling like diamonds around its hazy form. These moments aren't scripted, they're raw, real-time revelations that make astronomy addictive. Each comet has its personality. Some burst bright and fade fast, others linger like old friends. Our target today, Comet 3IATLAS, shares that lineage, and capturing it now in its fading phase adds a poignant layer. It's a reminder that these visitors are transient. Blink, and you might miss them forever. As we prepare, let's delve deeper into the science behind comet observation to heighten your appreciation. Why do comets move the way they do? Their orbits are governed by gravity, following Kepler's laws, elliptical paths with the sun at one focus. For long-period comets like this one, periods can span thousands or millions of years, perturbed by distant gravitational tugs from stars or the galactic tide. Comet C 2023. A3's orbit is hyperbolic, meaning it's not bound to the sun. After this visit, it'll escape into interstellar space, perhaps never to return. That's mind-blowing. It's a one-time guest. Its speed? At perihelion, it zipped at over 100,000 miles per hour, but now, farther out, it's slower, yet still clocking tens of thousands miles per hour relative to Earth. That's why, in telescope views, it appears to crawl across the star field, a parallax effect from our vantage. The color? Often reddish from dust scattering sunlight, or greenish from ionized gases like cyanogen. In our case, expect a subtle red hue, a signature of its composition. And the trail? That's the dust tail, particles reflecting light, sometimes curving due to solar radiation pressure. Observing this requires dark adaptation. Let your eyes adjust for 20 to 30 minutes, and a sight away from city lights, ideally with a Bortle scale of 4 or lower for optimal contrast. All right, the moment of truth approaches. Wish me luck as I align the telescope. The mount whirs softly, slewing to the coordinates. Right ascension, around 18 hours. Declination plus 22 degrees, adjusting for our location in the northern hemisphere. Stellarium confirms the position, cross-referenced with NASA's real-time data. The sky is darkening, Venus gleaming in the west, Saturn rising in the east. I scan the field. 1, 2, 3, 4, 5 stars in a familiar pattern, with a faint companion twinkling nearby. There, the target zone. Heart pounding, I fine-tune the focus. And there it is. A subtle smudge against the velvet black. Not a star, but something diffuse. 1, 2, 3, 4, 5. Counting the reference stars again to confirm. The object emerges precisely where predicted. Look at that trail. A faint streak, evidence of its motion. It's not static like the stars. It's shifting ever so slightly as we watch. This is it, folks. The comet. No enhancements, no post-processing. This is pure, real-time astronomy. Bam! There it is. Comet C 2023 A3 in all its subtle glory. We're witnessing history unfolding live. No BS, no manipulation, just the unadulterated view from our home setup. Finally, after alignment, tweaks, and filter adjustments, it's locked in. The right combination of luminance filter and exposure time darkens the background, letting the comet shine through. We've got just a few precious minutes before atmospheric turbulence or dawn interferes. But in this window, magic happens. See how the object is moving? It's elongating slightly, not round anymore because we're not tracking its proper motion perfectly. The telescope follows the stars, but the comet dances to its own beat. That fattening is the telltale sign of its velocity. And the color? Yes, it's reddish, a warm glow from scattered dust particles. At this distance, currently about 2.5 astronomical units from Earth, or roughly 230 million miles, the movement isn't dramatic like a meteor, but it's significant. This comet is hauling. Its orbital speed means it covers arcseconds per minute in our sky, a huge shift for such a distant body. What's weird? Its speed defies intuition, fast enough to escape the solar system eventually, yet appearing serene in the eyepiece. Now that we've locked onto it, let's unpack what this means and why it's so engaging. This isn't just a dot, it's a dynamic world. The coma, the hazy envelope around the nucleus, is visible, perhaps 10 arc minutes across, glowing from outgassing. If we're lucky, a hint of the tail extends, pointing away from the sun due to solar wind. Observations like this contribute to science. Amateur astronomers often report positions to bodies like the minor planet center, helping refine orbits and predict future behavior. For instance, during its 2024 peak, thousands submitted data revealing unexpected brightness surges from forward scattering, sunlight bouncing off dust at certain angles. Now, in 2025, it's quieter, but still teaching us about comet evolution. How does it fade? As it recedes, less heat means less activity, the tail shortening, the coma shrinking. By October 2025, it'll dip below magnitude 18, telescope territory for pros only. Catching it now is timely, a farewell to a once brilliant traveler. To keep you hooked, consider the broader implications. Comets like this could be keys to understanding life's origins. The Rosetta mission found organic molecules on 67P, and NASA's upcoming Comet Interceptor aims to rendezvous with a pristine long-period comet. Imagine, water on Earth might partly come from comet impacts billions of years ago. Studies show isotopic matches between comet water and our oceans. Plus, they're hazards. Think the Tunguska event in 1908, a comet or asteroid airburst flattening forests. Monitoring them via surveys like ATLAS, which co-discovered this one, is vital for planetary defense. NASA's DART mission in 2022 proved we can deflect threats. Comets add complexity with their volatile nature. Let's expand on comet types to enrich your knowledge. There are short-period comets, like Halley's, orbiting every 76 years from the Kuiper Belt, and long-period ones like ours from the Oort cloud. The Oort cloud extends up to 100,000 astronomical units, a light year away, home to trillions of objects. Perturbations send them inward, sometimes becoming sun grazers that vaporize near the sun. SOHO satellite spots hundreds yearly. Our comet survived its close shave, unlike some. Famous great comets, Hale-Bopp in 1997, visible for months at magnitude -1, Hyakutake in 1996 with a 100-degree tail, West in 1976, disintegrating post-perihelion. Each tells a story of survival or demise. Back to our view. The comet holds steady, its red tint evoking Martian dust storms. Movement is subtle, but real. Over minutes, it drifts relative to stars, a parallax poetry. This fast object puzzles. Why so speedy? Its hyperbolic orbit indicates an interstellar nudge, perhaps from a passing star eons ago. Speed calculations. Escape velocity from solar system at Earth's distance is about 42 kilometers per second. This one's exceeding that outbound. As we observe, let's troubleshoot common pitfalls to educate. Light pollution? Use narrowband filters. Atmospheric seeing? Wait for stable air? Tracking? Go-to mounts automate? Software like Stellarium or Sky Safari, perhaps what SkyEye referred to, democratizes access. Download and try yourself. To encourage sticking around, tease, upcoming, we'll analyze the image, compare to predictions, and discuss future comets, like C 2025 A6, Lemon, brightening to magnitude 4 to 5 by fall 2025, naked eye potential, or C/2025 K1, Atlas, at 7.5 in October. Stay for the full reveal. Diving deeper into history, Edmund Halley predicted his comet's return in 1758, proving orbits. Modern tech, Hubble imaged Hale-Bopp's nucleus. Stardust sampled Wild 2 in 2004, finding glycine. Our backyard view connects to this legacy. Current updates. As of August 2025, Comet 2023 A3 at 16.8 magnitude. Position right ascension, 18 hours 1 minute. Declination, plus 22 degrees. Other comets, 240p/NEAT at 13.8. Brightening, C/2024 E1 at 13.6 to 5 mag in 2026. Personal touch. The thrill is universal. That aha when it appears. Share your stories in comments, but focus on wonder. Extending. Comet myths. Mayans saw them as gods. Europeans feared plague. Science dispels, reveals beauty. Composition, ices, water, CO2, organics, methanol, minerals, silicates. Spectra show emissions. Observation tips, red light flashlights preserve night vision. Warm clothes for long sessions. Future, Comet Interceptor launches 2029. Lucy mission to Trojans, comet relatives. Wrapping up, but not yet, more to explore. The trail thickens slightly. Movement accelerates visually. Analogies. Comet-like time capsule, unlocking past. Encourage, watch to end for final analysis. Is it fragmenting? Color shifts? As we continue, let's dive into the emotional resonance of this moment. Picture yourself standing under a canopy of stars, the telescope humming softly, the night air cool against your skin. This isn't just about science, it's about connection to the universe, to history, to each other. Every comet we chase links us to ancient stargazers who marveled at the same sights, unaware of their true nature but captivated nonetheless. Today, we blend their wonder with modern precision, creating a shared experience that transcends time. This comet, C 2023 A3, is a fleeting guest, and capturing it feels like catching a falling star. The thrill of seeing that faint red glow, knowing it's a relic from the solar system's dawn, ignites a spark of curiosity that can inspire a lifetime of exploration. So, stay with me, let's savor every second of this cosmic dance. Now, let's explore the technological marvels that make this observation possible. Beyond the telescope, consider the software ecosystem powering our hunt. Stellarium, for instance, isn't just a star map, it's a digital universe, plotting millions of stars, planets, and comets with data from the Gaia mission and beyond. NASA's Horizons system, meanwhile, crunches numbers from decades of orbital mechanics, factoring in perturbations from Jupiter to passing stars. These tools, freely accessible, democratize astronomy. Anyone with a laptop can plan an observation like this. And the CCD camera? It's a game changer, capturing photons over seconds to reveal what the eye can't. This synergy of hardware and software transforms a backyard into a portal to the cosmos, making moments like this not just possible, but profoundly rewarding. Stick around to see how we tweak these tools live for the perfect shot.